I'm a theoretical physicist. Some of you might be wondering what that entails, what kind of activities I spend my days doing. Others of you will have come across people like me before, and you'll know that I mostly spend my time being a pedantic little git. That's right, I'm a complete nightmare. I only got into academia because it's one of the fields where you're allowed to argue with people about things that nobody cares about. If you pick your conferences correctly, you can argue with hundreds of people simultaneously and get a free holiday in. Just picture it now, me standing in a room full of hundreds of people, letting them all know that I'm a theoretical physicist. Of course, they're theoretical physicists too. We're at the same conference, so we have the same job. But then we head on down to the conference bar and get nice and sloshed and talk about our podcasts, how many degrees we all collectively have, and what our favourite interpretations of quantum mechanics are. But don't let me convince you that we don't talk about hard-hitting topics in science and physics. Let me talk about one of the most important topics in physics today. It's not sexism in the workplace. And look, it's not sexist to say that men just don't belong in physics. It's not their fault they get distracted and start doing things like inventing the atomic bomb, but it's not a good reason to have them around the lab. It's not sexism in the workplace. It's not even the difficulties of communicating the importance of physics research at a time where academia is dismissed as elite and out of touch. I mean, why spend $5.5 billion annually on infrastructure, public health, or welfare systems when you could spend it on an underground circle to make particles go boom? It's not sexism in the workplace. It's not the difficulties of communicating the importance of physics research at a time where academia is dismissed as elite and out of touch. No, none of those. It's the scientific implications embedded in the film Honey, I Shrunk the Kids. In the film Honey, I Shrunk the Kids, a scientist is constructing a mysterious laser device in the attic of his home. Now, for those of you who may be unfamiliar with scientists and how we work, let me assure you, we do all our best and most dangerous work in the attics of our own homes, in our nice suburban areas, where we can endanger the lives of our children and the children of our neighbours. We also don't wear goggles when we're dealing with lasers. It turns out the machine is for shrinking things, and in a startling series of hilarious hijinks, will, eventually, shrink the kids. Let's talk a little bit about the mechanism by which this happens. You see, it's very clearly explained in the film that all matter is made up of not only density, but also empty space. Now, that's the kind of statement that makes me think they wrote this part of the script by getting drunk and throwing darts at a board with words plucked from the AQA physics syllabus on it. You can't really say matter is made up of density. Density refers to the amount of matter contained in a specific volume. Saying matter is made up of density is kind of like saying tea is made up of hot. But let's sweep over that for now. What this film wants us to believe is that when the machine shrinks things, all it does is remove empty space, reduce the distance between atoms. No matter is removed from the system. Now, this of course would involve selectively changing the strength and range of the electromagnetic, weak and strong forces that govern the behaviour of electrons and atomic nuclei. I don't even want to think about what that would imply for our models of the universe, the Big Bang, black holes and the inevitable heat death of the universe. I don't even want to think about what it might imply for nanotechnology here on Earth. But let's come back to the salient point here. When the children are shrunk, the only thing that changes is that empty space is removed from the system. They weigh exactly the same. So when this film asks me to accept that two of the children, after having been shrunk, are able to ride on the back of a bee, I must logically also accept that bees would, if not for their small size, be capable of carrying humans on their back like horses. In this universe, bees are as strong as horses. Bees are as strong as horses. In a world with super strong bees, we should have harnessed this technology long ago. We measure engine power in roughly the equivalent number of horses. What would happen if we used bees instead? The Saturn V rocket, which was one of the most powerful engines ever built and carried humans to the moon, has approximately 160 million horsepower. Now, of course, we couldn't have used horses. Horses can't fly. And 160 million horses is not a convenient number of horses to carry around. Bees, on the other hand, are a lot easier to deal with. 160 million bees is nothing. That's only 18,000 kilograms of bees. And for those of you who like to deal with your bees by volume, that's 100,000 litres. The Saturn V rocket used approximately 2 million litres of liquid fuel in the form of kerosene and liquid oxygen and generated 350,000 tonnes of carbon dioxide. The alternative B-powered Saturn V rocket would generate no carbon dioxide and take up only 5% of the volume. So the real question we have to ask ourselves here as scientists is, in the inexplicable 2 sequels that got made of this film, where is the bee-powered clean energy revolution? We, the people, demand bees. And that's why theoretical physicists don't get invited to parties.